Okay, so let us see, student, the question number 59. Yes. Sorry, just wait. So, question number 59. Yes, given that input voltage VI, triangular input voltage VI is given. Okay, so and it is applied to this circuit. Yes, it is applied to this circuit. If you see here, applied to this circuit, this is like what, half wave rectifier. Half wave rectifier. So now see, and he is asking what is the DC? What is the DC voltmeter reading? Yes, what is the DC voltmeter reading across the diode? Across the diode. Yes, across the diode. DC voltmeter reading across the diode. Okay, so DC voltmeter reading across the diode. So now see here. First of all, if you see during positive cycle, and if you see the given diode is what, ideal. Diode is ideal. Given that diode is what, diode is ideal. Diode is ideal. Given that diode is ideal. Given that diode is ideal. Okay. So ideal means what? VD 1 in forward. VD1 is equal to what? 0 volt in forward bias. In forward bias. In forward bias. And forward resistance is given as 2 ohm. 2 ohm. Yes, 2 ohm. Now see, when Vi is what? Positive. Okay. So during positive cycle, what we observe here, during positive cycle, this diode is on. Yes or no? So first of all, we want to find what this is over primary voltage. This is over secondary voltage. Yes, primary voltage, secondary voltage. If you see primary, secondary voltage upon primary voltage is equal to what? Secondary turn, number of turn in secondary is 2 divided by 1, which implies that V secondary voltage is equal to 2 times of V primary voltage. V primary voltage. Okay. So now see, V primary voltage. Now at secondary, it is step up transformer. Step up transformer. Now, step up transformer. Okay. So now see Vi of t. Now, during positive cycle of input, diode is on. Diode is on. Yes. Once the diode is on, then what we will find here? Once the diode is on during this positive cycle, during this what, positive cycle. So what we will see here? Now see, during this positive cycle, diode is on. Diode is on. So we will observe what here. So if you see, this is what diode is on means resistance R. Yes, resistance R, and this is what resistance, load resistance. Okay, so load resistance, and this is my Vs. This is my Vs, positive, negative. Yes, positive, negative, and this is 2 ohm, and this is 2 ohm. This is 50 ohm. This is 50 ohm. Yes, 50 ohm. So we just need to get my voltage across this. What? Voltage across 2 ohm. 2 ohm. So V2 ohm. So V2 ohm, if you see here, V2 ohm is nothing but V2 ohm is nothing but, if you see, this is 2 into Vs, 2 into Vs divided by 2 plus 50. So which is nothing but, if you see 2 into Vs means what? 2 into Vs is how much? 2 Vp divided by 52. Yes, 52 volt. If you see here, V2O is nothing but 4 by 52. Yes, into Vm. What is Vm here? 5.2. So which is nothing but 4 into 5.2 divided by 552. So therefore V2 ohm maximum that we get is equal to 50 to 5.2 get cancelled. This is 0.1 means what, it is nothing but 0.4 volt. 0.4 volt. Yes, we get 0.4 volt. V2 ohm maximum. V2 ohm maximum when Vi of t is what, positive. When Vi of t is positive. Okay. So when Vi of t is positive, that time we get voltage across diode maximum of 0.4 volt. Maximum of 0.4 volt. Okay. So this is for during positive cycle. During positive cycle of input. So this is during positive cycle. Positive cycle. This is during positive cycle. Now see, during negative cycle. During negative cycle of input voltage. During negative cycle of input voltage. So what we will get here? Vs is equal to minus 2 Vp. Vs is equal to minus 2 Vp means diode is off. Diode is off. So let us see here, diode is off means what? Diode is off. Yes. So this diode is what? Off. During negative cycle. This is during positive cycle. Equation number 1. Yes. Now during negative cycle during negative cycle of input negative cycle of input. If you see here, Vs is equal to minus 2 Vp. Yes, here diode D1 will get off. Okay, so diode D1 will turn off. So therefore, what we will get here? So this is my input at secondary side. So this is open circuited. Yes, and this is what load. So this is what load, and this is my secondary voltage, positive, negative. Yes, so this is off because Vs is what? Negative. Vs is negative. So this is my 50 ohm load. Yes, and this is open circuit. And if you see here, open circuited, what is this? V2. So if you see V2 maximum, now see here, V2 maximum, we can say this V2 ohm is what? VDC positive, VDC positive. So this is what? VDC negative, it is what? Negative. So VDC negative means what? Once you will apply KVL here current is what? 0 ampere. Yes, whole voltage will get appear across this. Yes, so VDC negative is nothing but Vs. VDC negative is nothing but Vs, and that Vs is nothing but VDC negative is equal to minus 2 Vp. Yes, minus 2 Vp. So minus 2 Vp. So negative VDC minimum, how much we will get? VDC minimum, we get minus 2 Vp. Yes, 2 Vp means what? VDC minimum. VDC minimum that we get here, how much? Minus 2 into 2 Vm. Yes, so this is nothing but VDC minimum. VDC minimum is minus 4 into Vm is nothing but 5.2. Yes, 5.2. So 2 Vp. So just wait, 2 Vp. Yes, 2 Vp means what? Here 2 Vp. 2 Vp is, here Vp is nothing but 5.2. So this is nothing but minus 10.4 volt. 4 volt. So this much we will get VDC maximum. Yes, we will get this VDC maximum. This is what? VDC minimum. we will get VDC minimum minus 10.4, and we will get VDC maximum how much? 0.4 volt. 0.4 volt. Yes, 0.4 volt. So this is all about that we get. Yes, that we get across this VDC. Across this VDC, then we when we apply this input voltage, okay, input voltage into this circuit of what? Half wave rectifier. Half wave rectifier. So now see again what we will get finally. Finally we got what? Finally we got VDC maximum 0.4 volt, VDC minimum minus 10.4 volt. Minus 10.4 volt. So just let us see here. Now we are going to find what? DC voltmeter reading. Yes, DC voltmeter reading. So now see DC voltmeter reading. What we will get here? DC voltmeter reading, as we got here VDC maximum. VDC maximum is how much? That we got 0.4 volt, and VDC what? VDC minimum. VDC minimum that we got minus 10.4 volt. Yes. So this means what? Across DC, across this diode voltage, across this diode, we got what? The waveform like this. We will get waveform like this. VDC maximum is nothing but this here. VDC maximum. This is nothing but, if you see here, this is 0.4 volt. Yes, 0.4 volt. This is VDC. Okay, so this is VDC, and this is my, this is 0, this is pi by 2, this is pi, this is my pi by 2, and this is my pi, and this is my 2 pi. Yes, and this during negative cycle we will get VDC minimum how much? Minus 10.4 volt. Yes, minus 10.4 volt. Now what is the DC voltmeter reading? Yes, DC voltmeter reading means, what is the DC reading? DC means what? Average value. Yes, okay, so average. What is the average value? DC means average value. Yes, so now see, calculate DC. Calculate this DC voltage. Now this DC voltage, if you see the terminal is given what? Terminal that is given opposite to diode terminal. This is my diode terminal. Yes, this is my diode terminal, and this is what? DC voltmeter, DC voltage terminal. So this is what? Opposite. This is what? Opposite. So we will see here what we can write, minus VDC. Yes, why? Because it is given as opposite terminal of a diode. Yes, this terminal of this DC voltmeter is opposite to that of diode. So this we can say VDC1 maximum, VDC1 minimum. Okay, so now this VDC is nothing but, this is DC voltmeter reading, which is opposite polarity of the diode voltage. So now minus VDC is nothing but, this is nothing but 1 by time period into integration 0 to time period into VD into VD1 of t, VD1 of t dt. Okay, so this is what my VD1 means, what? VDC of t dt. So now see, minus VDC. Okay, so VDC is equal to what? 1 by t. Okay, so 1 by t means what? Time period is what? Here 2 pi. Time period is 2 pi. Okay, so time period is 2 pi. If we see this integration VDC, under this integration VDC means what? Area under this curve. Area under this curve is how much? If you see here, area under this curve is nothing but half of base. Area under this first triangle, half of base is nothing but pi. Half of base into height is 0.4. Yes, 0.4 plus area under this triangle, next triangle, this is half half of base, half of base into height. Base into height is nothing but minus 10.4. Yes, so minus 10.4. So now see here, minus VDC. Minus VDC is equal to what? 1 by 2 pi. 1 by 2 pi. So this is what? 2.2. 0.2 pi. 0.2 pi. Yes, 0.2 pi plus minus. It will get minus. This is 2 minus. This is 5.2. 5.2 pi. Yes, 5.2 pi. So this is nothing but minus VDC. VDC is equal to what? Is equal to, this is 5 point minus 5.2.2. This is nothing but minus 5 pi divided by 2 pi divided by 2 pi, which is nothing but minus 5 by 2. Minus 5 by 2 is nothing but what? Minus 5 by 2 is nothing but minus 2.5. Minus 2.5 means what? If you see here, this is nothing but VDC. VDC is equal to what? Minus VDC is equal to minus 2.5. 2.5. Yes. So VDC is nothing but what? VDC. If you see here, VDC is nothing but 2.5 volt. Yes. This is my DC voltmeter reading. This is my DC voltmeter reading. This is DC voltmeter reading. Yes. What we have done? Nothing. Just we have applied first during positive cycle. During positive cycle, diode is on. That time we have seen once the diode is on, there is a forward resistance of 2 ohm. Then after that we have applied what? Voltage distribution rule, and we got the VDC1 maximum 0.4 volt. Okay, 0.4 volt during positive cycle. Then we have seen what? During negative cycle of input voltage, then this diode is what? Off. This diode will get off. So therefore, whatever the voltage across the secondary, so whole voltage will get appear here, because diode is off. No current will flow through load. So therefore, whole voltage will get appear across this diode, across this DC terminal. So this is what? DC terminal. Okay. So therefore, we will get minimum. We will get VDC1 minimum is equal to minus 10.4. Minus 10.4. Okay. Once we will get this, then after that what we will do? So just we have to calculate what? Average voltage. Average voltage across this diode means DC voltmeter reading. DC voltmeter reading is nothing but the average, voltage that we will get across the diode. So that we have calculated here. This is nothing but DC average voltage across diode, which is nothing but DC voltmeter reading. And this DC voltmeter reading polarity is just opposite of that diode. So this is nothing but 1 by t integration 0 to t VDC t of dt. So this is area under, this is nothing but integration VDC t is nothing but area under this curve, that we have calculated, and we are left with this final answer, which is nothing but VDC is equal to 2.5 volt. Okay, so that's all about this question number 59, and the answer for this we will get option B. Yes, option B. So option B is correct for 59. Question number 59. Okay, so that's all for today. Okay, so thank you for supporting me and supporting my lecture. Okay, so thanks a lot.